Hey everybody. In this third part of our Excel for Data Science series, we're just going to cover something simple like correlation. So correlation can be calculated a couple different ways in Excel, and mainly we're going to focus on how to get all the pieces you might need to report this in like APA or AMA style. So the first thing you want to do is make sure your data is entered in tidy format from part 1, where each person gets their own row and each variable gets its own column. And so I've made up some data here with a pretty big correlation between the two variables, and we're just going to call those X and Y. The first way that you can calculate correlations is to use the Excel built-in function. And so in part 2, we talked about referencing cells and formulas. So to kind of bring those back up, we're going to hit equals to get a formula. The formula for correlation is coral, open parentheses. And this is where you can start highlighting. The nice thing here is that you can highlight the words and it won't freak out. Okay, so we're going to highlight X, going to hit comma, highlight Y, and then close parentheses. Because this is correlation, it doesn't matter which one you put first. X can go first or Y can go first. Hit enter, and we'll see that we have a correlation of around 0.5, which is a pretty big correlation. I'm in psychology, so that would be like, whoa, what's happening? Partially because it's made up data. Now, if I want to calculate that with the data analysis toolpak, because we're going to be using that more in this series, we can. Requires a little less understanding of the underlying functions for Excel. But what you want to do is you go to data and then go to data analysis. If you don't have this plugged in, I think we talked about this in video number 1, but for Mac, it's under Tools, Excel add-ins, and I clicked both of these. On Windows, I think it's under File. I had to Google it. So you want to make sure you have that if you're following along with this series. So I'm going to click Data Analysis. I'm going to go up here to Correlation. Hit OK. Now it guessed where my data was. I've also tested this already, but you would highlight all of your data. If you have labels in the first row, be sure labels in the first row is clicked. That's not automatic. And we'll let it stick it in a new worksheet for us. Now that also gave me the correlation, and the only advantage to using the data analysis pack is if you had 3, 4, 5 columns, you could actually do all pairwise correlations at once. So X1 to Y1, X1 to Y2, etc. And so you really just want to look at this piece here because everything else is the variable correlated with itself, which is why you get the ones. All right, going back to our data, next thing we want to do is maybe make a scatter plot. So we want to use some data visualization tools to see what's going on in our data. So to make a scatter plot, the easiest thing to do is to start by highlighting the data you're interested in. Go over to Insert, right, and we're going to pick Scatter. That's this one here. It says XY Scatter. Excuse me. Pick the first one, which is your sort of normal scatter plot without any extra lines. It's going to dump that right here. So let me take that scatter plot. I'm just going to move it down where we can see it a little better. Now, if I wanted to clean this up to be maybe a specific style, I may not like these lines. Kind of depends on the field that you're in. In Psych, we would never have those lines. And we want to add X and Y axis labels. So if we were doing APA style, we'd also get rid of this title. And then I could add the axis labels. So you'll want to click on the chart, go to Chart Design, add Chart Element, Axis Titles, Horizontal, Axis Titles again, Vertical. And then I can start typing on these things. So you click on it once and you can start typing. So I always hit Control A or Command A if you're on a Mac to get all of the title highlighted at once. Because if you delete all the letters and then accidentally click off, it can be hard to find it again. So I'm going to click on it once. I'm just going to call this X variable. You'd want to use something that was very descriptive of what the variable is, which we don't have at the moment. Oops. And then we would do Y variable here. And so we can do a lot of stuff to clean this up. We can highlight the entire graph and change it into Times New Roman, or Arial is another great font. To create a more readable graph. I don't know why It changed some of them and not others. Oh, there it went. And we could kind of play with this. Now, if in my scheme of made up data, I clearly made up pretty good data and I have one outlier here. So the good thing about data visualization is that now this allows me to see that this one dot does not really follow the pattern of other dots, because I originally made up a perfect correlation and made a mistake. So I changed this one. We could also add a line of best fit, but that would be more for regression. Okay, if you want to play with the colors of all these dots, you can double click on them and that'll pull up some format data series options. So there are lots of cool things that you can do with these graphs, but this would just be a nice way to visualize what this correlation looks like. All right. Now, getting into the more difficult part, which is calculating T and P for correlations. Okay, there are lots of cool online calculators, but I'm going to show you how to do this in Excel. Okay. Degrees of freedom is the number of things that are allowed to change and keep the same statistics. And basically, it's going to be, this is actually a typo, I'm sorry, this is n minus 2. 1 for x, 1 for y. So what we want to do is count how many people are in our study. So I'm just going to highlight this, and it's pretty easy to see this is 8. But as you have it highlighted, if you look in this top right corner here, it says A2. I'm going to do it one more time. You'll see it says 8 rows by 1 column. You can also look down here where the count is, and it'll tell me I have 8 people. So this is going to be 8 minus 2. And if you're like me and you're worried that the math is going to go wrong, you can do equals 8 minus 2, just so that you know it's 6. Our t value here is going to be this formula over here. So we want to take that correlation, so I'm going to do equals correlation, I'm just going to click on this cell here, divided by, and the square root function, sqrt for square root, not in caps, sorry, sqrt. And now we're going to have to play a lot with some open and closed parentheses to make it do please excuse my dear Aunt Sally or the order of operations. So I'm going to do one more parentheses for this top half of this square root here, so 1 minus r squared. So do 1 minus, click on cell A13 one more time. Do the caret icon, which is the one above the 6, so shift 6, 2. That'll give you the square of that. Close parentheses, do division, and now the division symbol, while we're doing the bottom half, we're going to do n minus 2, which is our degrees of freedom, so we're just going to click on degrees of freedom here. Close one more parenthesis to make sure the square root is the entire bottom, and hit enter. So our t-value is 1.45. Something I didn't test beforehand is how Excel treats negative numbers. So let's say we have negative 0.53 and 5.1, and we square it. Does it leave it negative? No. Okay, good. Sometimes data science calculators will square the number but leave the negative. Excel does not do that, which is good because we don't want a squared number to be negative because that's not appropriate. Okay. So our t-value is 1.45. Now the function we're going to use to get the p-value, given everything else we have, is t-dist 2t. This assumes a two-tailed test, which is the most common type of hypothesis testing. Generally, when you look at p-values for correlations, you're getting a two-tailed test. If you wanted a one-tailed test, you could divide this number by by 2, sorry. All right, so we would do equals t dot dist dot 2t, open parentheses. Okay. The first value is x. It says x here in the example, and this will be where the function explanations are useful if you hit function x up here. But that's where we put t. So I'm going to click on t, comma, degrees of freedom, here. Close parentheses, and that'll give me my p-value. So the p-value here is 0.2. You would use whatever criteria you believe should be, quote, significant, unquote. This is a rapidly changing area in at least statistical fields. But you could also just present this and say, this is actually a pretty large correlation, at least in my field. But in this case, I would not normally consider that significant at 0.10 or 0.05 or 0.01, whichever one I've decided to pick. Excuse me. But we could leave it up to the reader to decide. Right? So more than likely, a lot of this is not significant in traditional terms because we only have 8 people. Right? If I wanted to write this in APA style, I could do T, I'd type my degrees of freedom, equals I type my t value, p equals 0.200 when I end up rounding up. We could also include r equals 0.51. You'll notice that there is no leading zero on r or t because these values do not go over 1, but every field treats these a little differently. As that's your quick and dirty how to do correlations in Excel, calculate those t values, those p values, and maybe if you're one of my psych people following along, you could also write this up in APA style.